Hello friends, I am Chandan. In previous lecture, we will understand how what is the slope of isothermal process and adiabatic process. Now, this is the lecture of realization of different process. We will understand how we understand that this is a constant volume process or constant pressure process or adiabatic process. Okay. Now, this is my handwritten notes. The PDF link is given on the description. You can download it from description link. Uh, this is helpful for GATE, ESC, ISRO, DRDO, BARC and other competitive exam. You can follow me. And the Telegram link is given on the description. You can join it. Now let's try to understand what is the relation of different process. First, we will understand constant volume process. Constant volume process. That means if any question the rigid vessel is mentioned in any question or rigid is mentioned in any question, you must consider that this is a constant volume process. Okay. So rigid vessel means there is a this is the rigid vessel here this is the rigid vessel. So rigid vessel means the constant volume process. That means volume is constant of that system. Okay. Now understand constant pressure process. Constant pressure process. How to understand that process? Suppose consider this is our system here. This is our system. Okay, this is our system. In that system, there, uh, here, this is the boundary of this. This is the boundary of the system. We focus on that system. Now, here there is a wall. Here there is a wall, and there is a piston is there upside. Okay, so this is the piston. Okay. Now, if you apply some heat from this side, from downward direction, then the system's molecule are heated. The system's the gas molecules are heated. Due to this gas molecule, the pressure is increase in that system. In that system, the pressure is increase, and if the pressure is increased, the piston gradually move upward direction. So if the piston gradually move or freely move, then consider it is a constant pressure process. Okay, then consider that it is a constant pressure process. Now if you want to calculate the gas pressure, that is system pressure, then this is the formula of this system pressure, that is P atmospheric pressure plus W by A. W is the weight of the piston divided by area of this piston. A means area of the piston. Okay, so this is constant pressure process. Now isothermal process, uh, next that is isothermal process. So how to understand this is a isothermal process? How to understand this process? Suppose consider this is our system. This is our system. Here in that system there is a wall is there. This is the wall, and the upper is piston is there. And here this is our system. This is our system. Now here suppose the initial position of the piston is this. So this is the initial position. This is the initial position 1 1. Okay. Now you apply some load. First initially you apply load, only this load. Then you apply this load. You gradually apply the load on the piston, and this after this load, after this load, and after this load. If you apply load gradually, the piston goes downward direction. Why? Because the weight of the piston is increased. Due to this, the pressure, the volume is decreased because the piston is going down and pressure is increased. So the final position of the piston will be 2-2. Okay, 2-2. So here the due to this increased pressure, the temperature gradually transfer from this side to environment. Okay, so this is an isothermal process. So in case of isothermal process, the process has to be carried out infinitely slow, means temperature remain constant through the process. So understand that if any process is infinitely slow process, then you consider at it is a isothermal process. Now, in isothermal process, in isothermal process, it not happen practically except natural process. So natural process are basically isothermal process, but in real condition, it is not happen practically. Yes. Now, in isothermal compression, because it is coming out and equilibrium. So here, if here in this system, here the piston is goes downward direction. The piston is goes downward direction. So due to this, the heat is coming from this system to the surrounding. Okay, so this is given in this. So isothermal compression, because heat is coming out and equilibrium. Okay, so this is isothermal process. Now in next process there is a adiabatic process. Adiabatic process. So adiabatic process means if in any question the insulated vessel is given or adiabatic is given or it is a very fast process is given, then consider that it is a adiabatic process. Okay, insulated, if any question there is insulated is given, if there is insulated is given, then consider it is a adiabatic, it is an adiabatic process. So here this is our system. Here this is our system, this is the nozzle and the outside of this nozzle are insulated. So here the outside of this nozzle are insulated. Insulated means there is no heat transfer from this system to the surrounding, and this is the inlet and this is the outlet of this system. The inlet, that is 1 and outlet, that is 2. Now if in question the um, the notation, that is the picture is given in this way, there is insulated. So if this is insulated, that means it is considered that it is an adiabatic process. Or in any question, suppose it is say that it is very fast process, then consider that it is an adiabatic process. Okay, so okay, now in next topic, this is our next topic, that is ideal gas. Sorry, this is ideal gas. So ideal gas means basically we know the formula, that is PV equal to MRT, or you can say that PV equal to NR bar T. So PV equal to nRT, this is the equation number 1. PV equal to NR bar T, this is equation number 2. Now both two are ideal gas equation. So understand what is P? P is the absolute temperature. P is the absolute temperature. V is the volume. M is the mass. What is R? R is the characteristic gas constant and T is the absolute temperature. Okay, in equation number 2, P is the pressure, V is the volume, N is the number of mole, number of kilomole. N is the number of kilomole, R bar is the universal gas constant, and T is the absolute temperature. So remember this. Okay, now uh, here uh, here R is the characteristic gas constant, and these are different for different gas. But R bar is the universal gas constant, and it is same for different gas. For oxygen, suppose the R bar is 8.314, or for carbon dioxide the R bar is 8.314. Means it is same, the universal gas constant are same for different gas. So remember this data. R bar equal to 8.314 kilojoule per kilomole Kelvin. So remember um, this unit, that is kilojoule per kilomole Kelvin. Okay, now so here this is equation number 1 and this is equation number 2. Now we will understand, suppose this is 1, equation number 1 divided by equation number 2, you will get, so you will get 1 by 1, that is equal to mr by nr bar. So from here you can say that mr equal to nr bar. Okay, now mr equal to, we know that n equal to m by m, n by m, so n equal to m by m. So mr, that is equal to, for replace this value, m by m into r bar. So cancel out, and r equal to this formula, this is very important, r equal to r bar by m. What is m? M is the molecular weight. Thale, what is m? M is the molecular weight. Now suppose here this n equal to m by m. M is the mass and m is the molecular weight. So this relation is very important. R equal to R bar by m. R bar is the universal gas constant and R is the characteristic gas constant, and m is the molecular weight. Okay, now if you want to calculate the R value of oxygen, so we know the formula R equal to R bar by m. So here R bar, what is the value of R bar? That is 8.31, and what is the molecular weight of oxygen? That is 32. So if you calculate this value, this will be 8.31 divided by 32 kilojoule per kg Kelvin. Okay, kg Kelvin. So kilojoule per kilomole Kelvin, here kilojoule per kilomole Kelvin, and this is kilomole, kg per kilomole. Okay, what is the molecular weight? Unit of molecular weight, that is kg per kilomole, and if you multiply this, then kilomole per kg. So if the formula of R, that is the unit of R, that is kilojoule per kg Kelvin, and the value will be 8.31 divided by 32. If you want to calculate the R value, characteristic gas constant for carbon dioxide, then 8.314 divided by 44. 44 is the molecular weight of the carbon dioxide. Okay, so unit will be kilojoule per kg Kelvin. If you want to calculate the characteristic gas constant for air, then it will be 0.287. If you want to calculate this value, 8.31 divided by 29, 8.31 divided by 29. If you calculate this value will be 0.287 kilojoule per kg Kelvin. So in that way you can find the characteristic gas constant for air. Okay, now there is some data is given, that is favorable condition. So the gas uh, the gas behaves like an ideal gas when intermolecular forces between molecules tending to zero. So when you consider this is an ideal gas when the intermolecular forces between the intermolecular forces are zero, tending to zero. So when the intermolecular forces are tending to zero, then you can consider that it is an ideal gas. So how it is possible? When density is very less, that is less density, or pressure is less, and if the temperature, that is large temperature, then you can consider that this is an ideal gas. Now, volume occupied by the molecule is very less compared to system boundary, system volumes or container volume. So here the volume occupied by the molecule is very less. Okay, and the gases present in the atmosphere can be treated like an ideal gas. So oxygen, carbon dioxide, nitrogen, Ag, He, Ar. Okay, and water vapor cannot be treated an ideal gas, and superheated steam can be treated like an ideal gas when it is mentioned in the problem. So remember this data on ideal gas. Okay, so this is very important for ideal gas. Okay, so okay, so the pdf link is given on the description. You can download the PDF, my handwritten notes, and there is a Telegram link which is given on the description. You can download it. You can join that uh, Telegram link for getting update from my video and all the handwritten notes. And like, share, subscribe my YouTube channel. Okay, thank you.